Now we can get started creating some scripts for the game. The first one we're going to make will be to control the alarm light. When the player triggers the alarm, we want the light to pulse. So create a new C# script called alarm light on the alarm light game object by selecting it and then clicking Add Component, New Script. Name the script alarm light. Remember to match the capitalization exactly as we're doing it. Click Create and Add, and then double-click on the icon to launch it for editing. We'll start this script by removing the defaults that Unity puts in so that we can start afresh. Remove the start and update function and the comments that are there with it. Now we have an empty class, we can add some class variables. Firstly, we'll need to make the public ones. We're going to make a series of floats as the parameters to control the different intensities of the light and how fast we fade between them. Firstly, the fade speed. We'll set a default of 2, but this can be tweaked later in the inspector if we like. Next, we'll need a couple more floats to represent the high and low intensity we want the light to fade between. 2 and 0.5 should be appropriate defaults, but again, we can tweak them later in the inspector if we want. We'll be using the lerp function to change between these two values. The way that we're using this means that the change in value slows down as it reaches its target. As such, we'll want to change the fade to the opposite intensity before we reach the target intensity. We'll need to have a margin within which we are able to change the target to its opposite. The last public variable we'll need is a bool that says whether or not the alarm is on. This needs to be public, not for tweaking in the inspector, but because we want to affect it from another script which decides whether the alarm needs to be on or not. We still need another class variable, although we can make this one private. This will be to store the intensity we're trying to fade the light towards. Now that we have our class variables, we can set up any behaviors we want at the start of the scene. We do this in the awake function. Add this now. Since at the start of the scene the alarm will be off, we want the light's intensity to be 0. We also want the first intensity the light transitions to when the alarm is activated to be high intensity. Now we have our update function where we will perform most of the script's operations. Add this now. The first thing we want to do in each update is to check whether the alarm on variable has been set to true. If it has, then we want to lerp the light's intensity between its current setting and the target intensity. We want to include the fade speed in the last parameter so that we can tweak how fast this lerp happens. Next, given that the light's intensity has been updated, we want to check if it's near enough the target intensity for us to switch the target to its opposite. For example, if it's heading towards the high intensity, if we're within the margin, we'll head towards the low intensity. To do this, we're going to make a new function which we will call in the update. Move below the closing of the update function and add a new function called check target intensity. So in this function, we need to know if the difference between the target intensity and the light's current intensity is less than the change margin. To get the difference between the target intensity and the light's intensity, we'll use a function called abs in the mathf class. It simply returns the absolute value, that is, the positive version, of whatever is passed as a parameter. If this is the case, then we need to set the target intensity to the opposite of what it was. So we check if the target is high. And if it is, we set the target to low. Otherwise, we set the target to high. With the check target intensity function finished, we can put a call to it if the alarm is on in our update function. Note that in this approach, the light's intensity will fade in and out smoothly, as the lerp's value will slow as it reaches its target. To simplify this, we could have implemented another useful function called mathf.pingpong. This is designed to simply return values that loop between 0 and a given value, but this would not look smooth as its transitions have a constant speed. That concludes what needs to happen if the alarm is on. But when the alarm is off, we need to turn the intensity back down to 0. Add an else to the if statement in the update function. And here we'll put a similar line to our light intensity lerp, but set the value to 0. That's all we need to do with this script, so save the script and return to the editor. You'll notice that all of our public variables will appear on the script component in the inspector. Now we have something else we need to do for the alarm. We need it to actually make an alarm sound. You may have noticed that there are some megaphone towers around the level. Each of these is going to play an alarm sound effect. For this, we need to set up a few things. Start by expanding Environment Stealth Static, then expand Props, and locate all of the prop_megaphone game objects. Highlight them all with Shift Selection, and now that they're highlighted, we can affect them all simultaneously. We'll start by tagging them all with the tag Siren. We also want to add an audio source component to each of them so that they can play audio clips. Click on the Add Component button in the inspector and go to Audio, Audio Source. Lastly, we want to make sure that the audio source is set up correctly. In the Audio folder in the Project panel, you'll see a clip called Alarm Triggered. Drag and drop this to the Audio Clip property. We don't want them to play this sound on awake, i.e. when the game begins, but we do want them to loop when they are playing it. Now is a good time to adjust the range of the towers. Do so by opening the 3D sound settings on the audio source component, and set the min distance value to a value of 5. You should see in the scene view that there are blue spherical outlines showing you the reach of these towers. If you want them to be louder in the game, you can adjust this value later. That's all we need to do for the setup of the alarm. Remember to save your scene now by going to File, Save Scene, and move on to the next assignment where we'll be creating a library of tags for use within our game controller.